Hello everyone, today we'll be solving question 7 on the General Comprehensive Chemistry class. And little Gus here was the one who asked me to help me solve this problem because he's having a bunch of trouble with it. Isn't that right, Gus? Yeah, he said he's having a lot of trouble with it. So let's get started. What is our problem, Gus? An engineer is working with archaeologists to create a realistic Roman village in a museum. Wow, Gus, that's pretty cool. Plan calls for 100 granite stones, each weighing 10 denarium. No idea how to pronounce that. I googled it. It's not real, so forgive me if I say it incorrectly. But each of these granite stones weighs 10 deranium, and deranium is the Roman unit for mass, where 1 deranium equals 3.396 G. So we're going to write this all down. Now I sound like a weirdo because people walk by us. They're like, well, why is this person talking in this diagram to himself to a bird? So we have 100 granite stones, and granite is GS because I don't write it all, equals, 100 granite stones, and one of these granite stones will equal 10 DN, which is deranium, not like write it at all, and 1 DN will equal 3.396 G. You got that all, Douglas? Sorry, I don't have a pen to write stuff down, so I'll do it all for you. But anyway, so far we need 100 granite stones, and this is what all the granite stones equal is. So moving on, the manufacturing process for making these granite stones removes 20% of the material, which we'll be getting into later. Go ahead and write that down. Manufacturing removes 20%. Just write that down so don't forget it for later. Okay? Then moving on, the question asks, if the granite is to be used has a density of 2.75 grams per centimeter cubed, write that down. Very, very important. Density equals 2.75 G per cm cubed. You got it down, Gus? Then the question is asking, what is the minimum volume that engineers should use to create the village? So basically, first of all, the question is asking for volume. So what is the volume, Gus? Well, first of all, we were given 100 granite stones within our original problem, and basically we need what that is in cm cubed. Because as you remember, volume equals length squared, or cubed, sorry. Basically, a measurement cubed is what volume is, and cm is cubed. So our volume in this problem will be cm cubed. So we need to convert this to cm cubed. Oh, someone else walked by. Sorry guys, we look like maniacs here. It's not the best idea to choose to record a video, was it? But anyway, moving on, guys. So I have my notes right here because I need to think about what I'm saying. So first of all, Gus, I hope you're aware of dimensional analysis, because that's what we'll be using. Yeah, it's crazy, Gus, I know. So first of all, we have 100 GS, granite stones. We have 100 granite stones. And we don't really know what 1 granite stone's volume is. But we know what 1 granite stone's what a granite stone is in deranium, and we know what deranium is to grams, and we know what the density is per gram of deranium. So then, what we have to do is we're going to have to convert 100 GS to DN, then DN to grams, then grams to cm cubed. And we'll get into the manufacturing reach 20% at the very end once we're all finished. Alright guys, so let's go ahead and do the dimension analysis. So we have 100 granite stones, yes, right? and we want to convert 100 granite stones to 10 DN. Well, if we're doing the notional analysis, you're not actually making the number bigger. You're just basically, we're multiplying this to convert it to another measurement. So we know 1 granite stone is equal to 10 DN. So 1 granite stone is 10 DN. So we're going to multiply 100 granite stones by 10 DN over 1 GS. Because remember, these are the same thing. 10 deuterium is the same as 1 granite stone. Meaning, this is basically the equivalent to multiplying 100 GS by 1. So our number of, our measurement is not actually changing. It's just converting to a different form of measurement. So moving on, once we've converted it to DN, let's go ahead and cross it out. We need to convert deuterium to grams. And we know per 1 deuterium is equal to 3.396 grams. So let's go ahead and plug that in. 3.396 grams, right, Gus? Over 1 DN. And this cancels this out. Now we've converted it to grams, but now we need to convert it to cm cubed. So we know that per 2.7, what this is saying is that this is per 2.75 grams, there's 1 cm cubed. So all we have to do is just flip it over. So cm cubed on top, 2.75 grams. Because it'll divide our total grams of 100 granite stones by 2.75, and this will give us how many actual cms it is, what the volume is of 100 granite stones. And then we can plug this into our scientific calculator. Hopefully you have one of those, Gus. Don't worry, just in case you don't, I do. So we're going to do 100 times 10 times 3.396. Divide and multiply all out. Then we need to divide by 2.75. And we're going to get like a very big number. Like this. I'll just write some of it out, but you'll get the idea. I'll write all of it out, why not? And that's that is exactly how much, an exact measurement, how much volume it will take to make 100 granite stones. But however, just a problem. When we actually manufacture this, we lose 20% of our mass. Meaning that if we were to go to our manufacturing factory and order this amount, we would actually get less than what we needed because 20% of this will be lost. So meaning, basically, we can write a formula out for this. So our conundrum is that we need, so our problem is we have the amount ordered multiplied by 80% will give us this. Sorry guys. I won't write the rest out, but you get the idea. Okay, I got it. So we basically just found out how much volume will be needed to make 100 granite stones. However, we know that will be 80% of how much we actually need to order. Because we'll lose 20% in manufacturing, meaning 80% will be left over. So 80% of the amount we ordered will be equal to this. So how do we find this out? Well, obviously, we just need to, as you know from algebra, you need to get units alone. So we divide this by 80%, and divide both sides by 80%. And for those unaware, 80% is equivalent to 100, I'm going to skip this step, 80 over 100. Because 80 per cent is equivalent to 100, so 80 per 100 is crazy, I know. However, you noticed we're dividing by 12. We're dividing our volume by 80%. And if you divide something by a fraction, you flip it over and do something like this. Because we're dividing by 80%, meaning you need to flip 100 on top and 80 on bottom and then multiply it. And I wrote 12, 20, 34 out right there, but don't actually do that in your calculator. Use this number. I just wrote 12, 20, 34 out there because I didn't feel like writing it all out again. Sorry, guys. So then we need to plug in this number to our calculator, multiply it by 100, then divide by 80. And this is the exact amount in volume, the exact amount of volume in cm cubed that we'll need to order. And this will give us 1543.6364 cm cubed. And this is our answer right here.